7th period. Go ahead and say hi. Hi. Okay, so this is your first exam for Honors Bio. And I want you to do an awesome job. I have seen you do great work so far this semester, so let's finish strong, right? So, first of all, just remind yourself about what you're going to be ready to do when you walk in, so there are no surprises. I'll probably remind you that the next unit calendar is up and posted on my website. I'll probably remind you that we're going to have our UN sustainability goals on Thursday, and to maybe consider who you want to work with and identify which goal you think is most interesting for you to talk about. If you're going to work in your testing teams, otherwise we might just need to be prepared. You don't need to do anything ahead of time. We're going to do it all in class on Thursday, and you're going to find a little bit about that, but I'll probably remind you of that. I'll also remind you that you need 5 pieces of paper, all the same size per testing team, okay, per testing team. So I don't know if you want to decide who's going to do that so you're not surprised in the morning. And what you'll do is you'll put the 5 sheets of paper off the end of your lab bench so I can go around and stamp them before the test starts, okay? Then you will go and move into your group part of your test, and your group part of your test will have 5, that's going to drive me nuts, we'll have 5 questions on it. One of them will be a chi-square problem, so you want to make sure you're comfortable with how to do a chi-square problem. We can talk about that. One of them will be an additional objective or a combination of additional objectives, so you want to be prepared for that. One will be some kind of content, usually from every, if you have 3 content questions, and so every chapter is addressed. You want to write neatly. You can make boxes, you can make tables, you don't have to write in complete sentences, but you need to respond to the prompt that I give you. And you'll have 1 sheet with 5 prompts, and then you can kind of work on it. That takes the longest time, all the writing, so you have about 37 minutes or so to do that portion. When you're done, you will staple the prompts with all your names on it to the 5 pieces of paper in order, and you'll hand it to me. Then you'll just sit at your lab station until everybody's done, or when time runs out. And that's sad if I'm like, give me your paper, and you're like, but I'm not done. And I'll say, give me your paper. Okay, so you will have an adequate enough time if you're working well together collaboratively, and you can work with anybody you want, but we want to keep teams to 4. Okay, you'll turn those in. Then you'll move on to the multiple choice portion of the test. The multiple choice portion of the test, you'll have a Scantron, and you will then have a test. And whatever version you get, you'll make sure you write it down. And you're going to put your alpha number on it. Do you remember your alpha numbers when I had you turn in your debriefs? It's that same number, okay? And you're going to write that on your Scantron. I'll show you where. Okay, then I will give you a cover sheet for you to use to cover up your Scantron and while you're working. And then I'll pass out an exam to you. And it's like 5 pages or back front, 5 pages, like 3 or 4 pages stapled together. And then you'll just work through those problems. And some will be super easy and some you might have to think a little bit. And you can't write on the test, but you can, what I'll tell you tomorrow is if you read a question and you bother to read the question, then bother to give it an answer, just a temporary answer at least, what your gut reaction is. And I would tell you to go outline the box of like A, B, C, D, E, and you think it's C, outline the box of C. You don't have to fill it all in, but at least outline it because you've given it some thought. And then when you come back, you can see if you agree with that or you need to erase it or fill it in however you need to do. Does that make sense? I just want you to feel comfortable so nothing I say is going to surprise you. You will have the rest of the time to work on your multiple choice. And then at about 5 minutes before class is up, that will be all the time. Whatever time parameters I set in first period, however much time they have during first period, that's the same amount of time that everybody gets. If something goes wrong, it can go in. Everybody gets the same amount of time, whatever we set it at first. So even though third period has a little bit longer class, they have the same amount of time as first and fifth. Does that make sense? Try to keep it a constant, right? And then while you're doing the multiple choice part of the test, I will be grading your group part as fast as I possibly can and calling you up during the test and giving you your group grade score. I will not allow you to have the thing back because there will be other people that have other tests or makeup tests, but you'll have an idea there. I usually try to get them graded that night if I can too. You'll know your score tomorrow night. If I'm on my game and nothing interrupts. What am I doing tomorrow? It'll probably be later in the evening, but I'll try to have them up by tomorrow. Okay? It won't be a part of your progress report because the progress report session ended on Friday. So whatever your grade is, your grade is. What still is going to go in that's not in are your debriefs. Will go in, and those count towards the first progress report. And I'm probably not going to get your labs graded tonight. So, but if I do, then those would go in. If, like, miraculously I got those graded. Okay? Now, content-wise, of what kind of thing I could ask you. So I've kind of broken it down, 33, 34, and 32, because that's the order that we went through it. Did I hit start? Oh, yeah, I did. That'd be a bummer. Okay, so on chapter 33, things like knowing the definitions of terms we used all the time, like ecology, I would know that for sure, right? Because there'll be some questions where I ask you to apply it, and if you're not even familiar with the vernacular or the terms, then that'll make it a lot harder. This is exactly the same as this. It is not any different. All I did was give ourselves some space so we could address each issue. That's all I did. Okay? So what is ecology, by the way? Anybody? Bueller? What is it? Communities and their environment, right? Abiotic, biotic factors, right? Okay. Now, the next thing I asked you to do is characteristics of population, types of growth curves. What are the two types of growth curves? Exponential, and we call that a J. And what's the other one? Logistic. Okay, logistic. Good. All right. And what runs right in the middle of this right there? What's that? Carrying capacity. Now, it's spelled carrying capacity with a C, but the symbol is K. Remember that, right? Now, if this part's hard, remember on my YouTube page, I have reviews of each of these chapters individually. So you could just go watch just the 33 YouTube review, just the 34, just the 32. Those are all individually capsulized if one of those chapters was hard for you. And then I go into more details about each of those things. Okay, and you would be able to label different things like they're both exponential. I drew that a little steep. I don't like the green one, sorry. Somewhere in there. That would be a little bit better. What was wrong with the first way I drew it?
You didn't show environmental resistance.
Exactly. I didn't show environmental resistance. Now that shows real application if you can figure out how a graph is drawn incorrectly. Okay? So we want to show, and obviously like there was a plague there, some environmental existence. Good. R versus K. What does R versus K mean? Do you remember what R versus K is? Yes.
Exponential, right?
Exponential growth versus equilibrium. Do you remember opportunistic versus equilibrium? You could relate it to that. That would work. Regulation of these growth curves. Density independent, density dependent. What are density independent factors? What are those types of things? Weather. Anything that is what?
Natural. Abiotic.
Usually abiotic, right? Abiotic things. Okay? Whereas density dependent factors, these things come into play as you get closer and closer to the what? Carrying capacity. So you're going to get more competition when you get closer to the carrying capacity. You're going to be filled to the limit, so your population's probably going to be crowded, so you're more likely to get disease, right? All of those things happen as you get closer to the carrying capacity, and those are density-dependent factors. Biotic potential. Do you remember what biotic potential? There are 4 factors that contributed to an organism's biotic potential, like when they start reproducing, right? Do they survive to reproduce? How many young do they produce? How often do they reproduce? Those are all things called your biotic potential. Survivorship curves. Survivorship curves all start at the same point. Do you remember where they all start at? 1,000 individuals, right? And then there were 3 types of survivorship curves. What type are you? And what does a type 1 survivorship curve look like?
It goes from the top of the dog.
Yeah, so more like this, right? And so most of us live out our lifespan and we die when we are old, okay? And that was a type 1 survivorship curve. What's the other type? What would be the opposite of that? Type 3. And in type 3, what happens? Yeah, a lot die. And then what falls in between that would be a type 2. Good. Okay? And I would have an example of an organism for each one of those, right? If I said mosquito, where would you put mosquito? Type 3. If I said weeds, where would you put weeds? 3. How about birds? 2. How about bears? 1, because they're large mammals, right? Now, those large mammals, those type 1, would you call those equilibrium or opportunistic? Which one would you call them? Equilibrium, right? They invest in their young. They only have a few young, right? We talked about that. Habitat versus niche. Habitat is where you live. Niche is what you do. What can you have multiples of? You could have one habitat with several different niches within that one habitat, right? But we know the competitive exclusion principle says no 2 species can what? The exact same niche for long, right? You might separate it over time. I'll take it in the morning, you take it in the evening, or we can partition it physically. I'll take the west side, you take the east side. And when you talk about that, that's called resource partitioning, right? Resource partitioning. Yes?
Going back to abiotic and biotic.
Yes.
With the spread of disease, would that be
Biotic. Yeah, because the spread of disease is more likely to happen when you're crowded, and if you're crowded, you're probably near your carrying capacity or above it. Yeah. Yeah, it's not like animals get to their carrying capacity and they go, uh-oh, and they just stop. They go above, below, above, below, above, below, right? And if they're above, what's gonna bring them back down? Lack of food, right? Lack of mates, lack of a place to live. All those things are gonna be competing for. All right, humans and age structure diagrams. We talked about less developed countries and more developed countries. How many age structures were there? Really? I remember 3. Do you remember what they were? Pre-reproductive, reproductive, and post-reproductive, right? And MDCs have a more stable age structure diagram. The numbers entering reproduction are about equal to the ones leaving. And we said that there can be a transition between a less developed country with its heavy pre-reproductive and population exploding. We could get from an LDC to an MDC, and what were some of the things that help us to do that? Medicine, education, hygiene, right? Those types of things where people are surviving and not dying. That will help move you from an LDC to an MDC. Okay, predator-prey. Do you remember on predator-prey dynamics where we saw some cycling? Do you remember that? Yeah. Okay. And so we saw when the predator numbers went up, then the prey numbers start to go down. And then when the prey numbers go down, the predator numbers go down. It could be because they've eaten all the prey. That could be one thing. They overate. Or maybe the prey didn't have anything to eat. Maybe there was a drought and they didn't have any grass to eat, so the prey numbers went down. And as a result of the prey numbers going down, then the predator numbers go down. But they're cycling. And we talked about usually prey wants to be a worse prey. You know, they don't want to be caught. And a predator wants to be a better predator, right? And so we talked about strategies for that. And some of those strategies, we said you could have toxins if you're a plant because you can't run away, or spines, or you could be in a symbiotic relationship with an ant or something if you are a plant. You could have thorns. We talked about mimicry. You could mimic your environment. You could mimic a rock. You could mimic a plant so you could stay hidden. Remember the spider? He was a good predator because he blended right in with the yellow color of the flower. Yes? okay, and the goat up on the hillside, and that worm, you couldn't even see it behind the leaf. So we talked about mimicry. Sometimes you really want to hide yourself. What do we call that when you're hiding yourself? Camouflage. Good. What if you're hiding yourself and you're looking like somebody who's lethal, distasteful, and you're tasteful? What kind of hiding is that called? Bayesian, and it's a lie. You try to get them to take the bait and think that you have a stinger too. What if you have a stinger and all your buddies have stingers and they're different species and you're like, we are the stinger group, but you're all different species? What kind of mimicry is that? So you're imitating each other, but you're all equally lethal, right? What about if I'm not trying to hide? What if I'm trying to stand out? Why do you think I'm trying to stand out? Warn you. Yeah, warning coloration. I'm notifying you. If you eat me, I don't want you to accidentally eat me. I don't want you to think that I'm just some other bug. I'm a poisonous bug, so I'm going to advertise that. What if somebody is not a poisonous bug, advertises they're a poisonous bug? What would that be called? Bayesian. Yeah, because they're trying to look like a brightly colored one, and hey, maybe they won't eat me. All right. Next, symbiotic relationships. There were 3 that I wanted you to know about, and we could summarize them with math symbols. What were the 3 combinations we talked about? Plus, plus. What else? And plus 0. What is plus, plus? Mutualism. And have an example for that. What is plus, minus? Parasitism, and have an example of that. And plus 0 is commensalism, and have an example of that as well. And I guess this is where we also talked about disturbance. We might have talked about the intermediate disturbance hypothesis. Does this sound familiar? Bless you. Jinx you. Okay. Intermediate disturbance hypothesis says in any community that it's good to have a little disturbances. Not too often, not too infrequent, but just an intermediate amount of frequency and an intermediate level, because it kind of clears cleans house, right? So that was the disturbance, intermediate disturbance hypothesis. Okay, any questions on chapter 33 that you came in here with because you're like, I already studied and I have questions, Miss Litton? Nothing? Okay, so then let's talk about chapter 34. So chapter 34, you could probably summarize in like 4 drawings or something. I think you could do it, right? So chapter 34, all the energy starts with the sun. Who captures the energy from the sun? Plants, right? And give me another name for that? Autotrophs, producers. Good. So they capture that energy. So we start with our producers. Okay? And then where does it go? Primary consumer. Okay? And these were our producers. What's another name for a primary consumer? Herbivore. Good. And what level are they at, though? Are they? Second trophic level. What level is this? First trophic level. And these are autotrophs, yeah? So this could be anything that eats those plants. Like it has to be good. He likes plants. Okay? So that is your first level. Then next, where do we go to? Who do we have next? Secondary consumers. What do you call them? Carnivores. What else? Good. And this could be anything that eats him. It's something. Okay, what's next? Tertiary consumer, right? Also a carnivore. And what level would they be at? Fourth trophic level. He's really big. Okay, and he's going to eat that guy. All right. Energy flows and chemical cycles. And when energy flows, it always starts with the sun, and every time it changes hands, about how much gets passed on? 10%. You might lose some as heat or just the metabolic activities of that particular organism, and that's why you don't get too many levels. Food chains, food web. What did I draw for you right now? A chain. Okay, but if I did this, right, now we're starting to look like a food web. Trophic levels we already hit, and then next you have your biogeochemical cycle. Oh, stacking trophic levels or ecological pyramids, remember that? I didn't write that on there. But when you stack the trophic levels, remember you could do it like a pyramid of numbers. So I have more blades of grass than I have horses, wild horses that are eating the blades of grass. And then I have more something that eats horses. I would have more horses than whatever ate them, yes? Does anything eat a horse? A lion, because they were at the zoo. And the horses got eaten by the lions, right? So you could do a pyramid of numbers, but sometimes that doesn't always work because you could have one tree with millions of ants on it. So the best kind of pyramid when you do your stacking pyramids is do a pyramid of what? Energy. Good. Okay, water cycle. Yes?
What's the difference between a food chain and trophic level?
Oh, a trophic level just identifies the position you are in the food chain or in the food web. Yeah. So a trophic level, if I'm at, the first trophic level, I'm some sort of autotroph. If I'm at the second level, I'm some sort of herbivore. Whether I'm in a grazing food chain initially, it doesn't matter. I'm telling you that's the role that I play. Okay. Water cycle. What are some key words in water cycle to know? Transpiration is evaporation of water out of plants. And evaporation, what else? What? Aquifer, underground water tables. What else? Exchange pool. Runoff. Precipitation. Those are excellent words. Okay, phosphorus cycle. What's the reservoir for the... Oh, also know how man screws it up. Okay, like pretty much pollute works for everything. And some have specific things though, but we do pollute our water, or we drain all the water out of the aquifers and you have sinkholes. That's how man screws it up. Okay, phosphorus cycle. What is the reservoir for the phosphorus cycle? Rock. How do you get it out of the rocks naturally? Yeah, erosion and weathering. And it's called a nutrient. Starts with an L. Limiting nutrient. So normally it's not a problem. You only have a little of it. Plants, autotrophs use it right away. And then herbivores can eat the plants, and carnivores can eat the herbivores, and it gets to the system. Decomposers break it back down. How does man screw it up? Too much. Fertilizers. What else? What? Mining, yeah, causing erosion and getting it in there. Cleaning soaps do it. Raising cattle and the runoff from the fecal material does it. Factories. So when you do that, you can get an algal what? Bloom in the water. And you would think, great, algae, plants doing photosynthesis, decreasing greenhouse gases, awesome. But the problem is you can't keep that up. So what happens to all the algae? It dies. Who's going to work on it? Decomposers. And what process do they do, just like us? Cellular respiration. What gas do they consume? Then who doesn't have any more oxygen? And then the fish? Right, death of a lake. Okay, good job. Nitrogen. Let's just do the nitrogen cycle. Yes.
For phosphorus.
Can't hear. Go.
For the phosphorus cycle, so the phosphorus gets into the rock, and then does the plant absorb it from the soil?
Usually gets into solution in the water.
Okay.
Yeah, from the runoff.
Okay.
Good. Okay, nitrogen cycle. And by the way, sometime, somewhere, it's on my YouTube channel. There's a video of me doing the nitrogen cycle, so you would be able to access it. Okay? Here we go, right here. What's the reservoir? Atmosphere. Okay, so we do nitrogen fixation by nitrogen fixing bacteria. And they're taking the N2 gas and converting it into what? Ammonia. Then we do nitrification. First, nitrite, this looks like an I. then nitrate. It's on a tray. Who are we going to serve it to? Plants, and then animals can eat the plants. Then the plants and the animals die. Decomposers put it back into ammonia. Nitrification. This is nitrifying bacteria when I say nitrification, right? Nitrogen fixing bacteria, then across the way here is nitrifying bacteria, right? Okay, first nitrite, then nitrate. Good. Now, what's a way to return it back into the atmosphere? Denitrifying bacteria. So they're going to take nitrate, NO3- and put it back as N2 up in the air. Yes? Yeah. Okay, so denitrifying bacteria. Now, there's other ways to get nitrate, which is what? Atmospheric fixation and industrial fixation. Good. Perfect. See how well you know that cycle? I bet you feel most confident with that cycle over all the other ones because you know all the steps. How does man screw it up? Pollution. Acid rain. All right. Carbon cycle. Carbon cycle. What do you think of when you think of carbon? I mean, there's carbon in our bodies, yes, for sure. But what do we primarily think of when we think about the... Hi, sweetheart. When we think about the carbon cycle? What? Savannah? No. Sure. But what is in the air? What's in the air? Carbon dioxide. Good. Okay. Who takes the CO2 out of the air? Plants, autotrophs, right? And they fix it. They take CO2 and they fix it into a solid. That's the remover. Is that the only remover? Yes. That's it. Plants. That's your only remover. What produces CO2 up into the air? Cellular respiration, combustion, any engine burning something, and decomposers who do cellular respiration. Okay, so they generate more CO2. So when we think about that cycle, we know of the air we breathe, 78% of it is actually what? Nitrogen, right? So a smaller proportion of it is oxygen. The only thing making the oxygen are the plants, right? So it would be imperative to maintain the plants, like not burn them like they are in Brazil right now, right? So we want to make sure that we don't cut down trees because the concern is as the CO2 levels rise, then you're going to create these are a part of what? Greenhouse gases, which leads to global warming, right? And glaciers melting and things like that. Okay, that is chapter 34. Those of you who have studied chapter 34, do you have any questions or concerns that you walked in here with that I did not address? Yes?
First versus second law of thermodynamics.
Do you want me to go over them? I don't think they're on your test. First law of thermodynamics is energy cannot be created or destroyed. Second law is, but change forms. But the second law is every time it changes forms, you lose some as heat. Good. What else? Anything else? You walked in here prepared. You're like, I've studied it. All right. Next, chapter 32 was all about behavior. And on behavior, the first thing you're going to need to be able to do is go, can I give you evidence of genetic, that your behavior comes from your genes? We went over a bunch of examples of those. Can I give you examples of behavior being learned? And we went into several things with learned. We talked about different types of learning. We talked about imprinting, right? We talked about associative learning. We talked about habituation. We talked about imitation, right? There were lots of different examples for that. So you're going to want to make sure you feel comfortable with all of them and then how they break down, like into classical and operant conditioning and all of that. Okay? Fixed action patterns. Are those learning? No. Fixed action patterns is you're behaving in a way, you have some releaser that triggers you. You know, a female presents and the male bird goes and has sex with her. Okay? A red color shows up and the fish attacks anything that's a red color. That's a fixed action pattern. They can be very complicated. Remember how we looked at the weaver bird building the nest? But do not give me that as an example of learning, because remember the weaver bird, if somebody dethatched that one thing, he didn't know how to go back and fix it, because once he'd moved on to tunnel position, he didn't know how to go back and fix the original nest. So fixed action patterns are not examples of learning. Okay? And make sure you understand about imprinting. Imprinting, about the sensitive period when they learn. We looked at birds and talked about how social interaction plays a role in that. Okay, associative learning. What were the two types of associative learning again? Operant and classical. What if you said operant, I said good job and gave you a cookie? That's operant. You performed the correct operation and I rewarded you. If you gave me the wrong answer and I went, that would still be what? Operant. Okay? Rewards and punishers. You did that operation and I either said good job or bad job. Okay? But if I hold a pizza here and you're kind of hungry and it's your favorite and I have like 5 boxes of pizza I'm juggling, I'm like, who will help me eat these pizzas? And you could smell them, right? Then that is not classical conditioning. It's if every time before a test I said, I think it's almost that time. I think it's almost pizza time. And you started salivating because you know the next thing I'm going to do is go get 5 pizza boxes. I don't have any pizza boxes for you. But if pretty soon I just said, if I think it's pizza time, you can't see them. They're not here yet. You can't smell them. But your brain is already associating with that and you're starting to salivate. Okay? We talked about dogs getting excited if you go towards where your leash is. That's going to be what? Classical. Okay. Next, mating behaviors. We talked about female choice, and what were the two choices what were the two hypotheses? Runaway and good gene hypothesis. Good. What one is your good looking? Runaway. Good. Okay, we talked about territories and defending territories. What does sexual dimorphism mean? Males and females look different from each other. Fitness is not your body fat or how fast you can run a mile. What is fitness in the biological world? How well you can pass on your genes. I just read, and I'll have to show it to you. I don't think I told you about it in class. It's this little Australian mammal. Did I already tell you this? When a predator comes, he throws his babies at him and then runs away. Because what they're thinking is, I guess, is if you're gonna eat me and I defend the babies, there's nobody to defend the babies from then on, so they're gonna die anyway. So I might as well just give you the babies to eat and then I'll run away. Okay, literally throws the babies at the predator and then runs away. Good parents. Sociobiology was about living together, and we talked about that you probably don't get to reproduce as much if you're living together. You might have a job you don't like, but the benefits must outweigh the cost, and so organisms do. We looked sometimes like organisms would stand up on a hill and they would scream, and that was their job to be a guard. And you think, why would you ever take that job? Because for sure you're probably going to die. And we said, is it altruistic? Altruistic is sacrificing your own reproductive success for somebody else's reproductive success. Are they being altruistic, and should they get a reward and a little medal pinned on their chest? No, they should not, because what do they care about? Their offspring, yeah. Except for that one in Australia who throws their offspring at them. And then we talked about communication. Does auditory work day, night, or both? Both. Good. Fast or slow? Fast. Visual, day, night, or both? And fast or slow? Tactile? Both. And I don't know, it's however long you can feel them, And what's the example we said for tactile? Bee dance. And the bee dance, when they are shimmy, shimmy, coming around, shimmy, shimmy, coming around, this right here, this shimmy, shimmy pattern tells us what? The angle from the sun. Yeah. Go out, turn left. And then the shimmy, shimmies are what? How far away? Okay, chemical, day, night, or both? Fast or slow? Slow. And then the last thing I would tell you is practiche your chi-square test, right? And I have a whole video I recorded on just chi-square test. Make sure you know how to do that. And look at the table. Yes?
Will we have access to calculators?
You should always bring a calculator. Yeah. Yes?
Do we have to draw a cycle?
What do you think?
Yes.
Okay. Yes. I can't hear. Shh.
If we need it, do we have access to a table in the chi-squares?
You will need it, and I have put the table on your test.
What are you pointing?
Yes. Guys, please don't talk. If you want to go, you go right ahead, but I'm answering questions, and I want everybody to be able to hear them. Go ahead.
Can you explain intersection versus intra?
Yes. Intra is within. So that's like male fighting another male. Okay? Intra is within. Inter is like female choice.
Okay.
Okay? Yes.
Use your stapler.
Oh, yeah, you can use my stapler. Okay, anything else about content? Yes.
Can you define altruism?
Altruism is reducing your reproductive success for the success of others. Oh, and I didn't review, remember reciprocal altruism? And what was the example of that?
The bats.
The bats. I'll scratch your back if you scratch mine. I'll give you some of my blood meal. Next time you'll give me some blood meal. Remember that? Okay. So it's not really altruistic because you're expecting payback. Right? Not really altruism. Anything else? Get a good team, get a good sleep, be ready to go. I want to see champions tomorrow. Champions! Get good rest.